Hey there. Today we're going to talk about section 2.3 and 2.4. So let's start with section 2.3. Section 2.3 is about graph equations of lines. So there's a few ways you can do this, but I'm going to show you the way I prefer. Say, for example, you're asked to graph 2x plus 3y equals 12. Now, I'll list the ways, but I'll only do it one way. Method 1 could be making a table. Method 2 could be using x and y intercepts. And remember, an x-intercept is when y equals 0. A y-intercept is when x equals 0. And then method 3, this is the way I prefer, is use slope intercept form. Slope-intercept form is the following: y equals mx plus b. So this is what I prefer. M represents slope, which we talked about in section 2.2. B represents y-intercept, which I already defined right here. It's when x equals 0, or when line crosses the y-axis. So now we can do this problem. So again, we have to graph 2x plus 3y equals 12. First step, solve for y. We did this actually in, I think, section 1.4. If I go back real fast, yeah, right here, section 1.4, rewriting formulas and equations. Solve for y of 2x minus 5y equals 10. So we see how we got y by itself there. This is how algebra works. Everything builds upon itself. So once we do that, so 3y will equal negative 2x plus 12. Y will equal negative 2/3 x plus 4. The second step is to plot the y-intercept and use slope to obtain a second point. So we'll do that right now. So here's 1, 2, 3, 4. And we make a few more tick marks here. So now I'll use a different color to plot these points. So we have 4. Remember, that's y-intercept. Because earlier, we found the y-intercept's 4. Remember, that's b. And that's m. And that's what I'll do next. If I look at m, since m is negative 2/3, that means down 2, right 3. The minus means down, but we always move to the right. Always go right. But plus is up, and minus is down. So from here, I'm going to go down 2 units and move over 3 to the right. So say I went down 2 and 3 to the right. So the third step, I think it's pretty obvious. We connect the 2 points. So third step, connect your 2 points. If I do that, I now have the equation of line. This is the way I prefer you go about graphing because it's more efficient, and it does solidify your algebra skills because you're working on trying to get a variable by itself. Making a table could be good, but if you consistently make a table, you're never going to quite understand how to do the more complex graphs because sometimes the table is not going to work out for you. You could find x and y intercepts, that could work, but again, it's not a very foolproof technique, especially if you plug it in correctly. So I would advise that you try to convert the slope-intercept form. I think there's a couple things from 2-3 that we should discuss. Here's just some more examples before I move on to 2-4. Let's say I asked you to graph y equals -4 and x equals 3. One, two, three, 4. Okay, now I'm back. The student had just walked in, so I had to pause the recording. So, y equals -4. It's going to be a little tricky. But it's actually going to be a horizontal line. You think of y being vertical, but y equals -4 is a horizontal line because all the y values are -4. You could have any x value you want because there's no restriction on x, but y has to be -4. If I change the color up, x equals 3. That will be x equals 3 because all the x values are 3. So it's a little weird to think of x being horizontal, but x equals 3 is actually a vertical line. So the best way to think about it is that how would the line look if all the x values are 3? So, for example, x value of 3, x value of 3, x value of 3, x value of 3, x value of 3. So it has to be a vertical line. So what I'll do now is just to avoid the same problems last time. I'll actually stop this video and make a second video for 2.4 because I'd hate for the same situation to happen where I upload and it gets rejected. So let me stop this video and there will be a second video for you to watch.